Okay, let's try another. How about rewrite? Let R be the parallelogram bounded by x equals -3, x equals 0, y equals x, and y equals x plus 1. Then rewrite the double integral over R of 2 times quantity x minus y dx dy using the following suggested transformation. So using the transformation, and the transformation that's being provided is u is equal to 2x minus 3y, and v is equal to -x plus y. Alright, so what I'd like to do is first solve for x and solve for y. We need to write x and y both in terms of u and v. So how about this? We'll take the provided u, which was u is equal to 2x minus 3y. How about we get the coefficient on x's to match? Notice that we only have a coefficient of -1. So how about we take that second equation, multiply by 2 on both sides. That'll be 2v equals -2x plus 2y. Okay, so, oh yeah, because these coefficients essentially match except for the sign, it will make sense to add the equations together. So u plus 2v is equal to, those cancel, and then we have here, what was it? This was a plus sign, right? Yeah, okay. -3y plus 2y, so -y. And then we would just, for convenience, multiply both sides by -1. So -u minus 2v, that's equal to y. Then we've solved for y. Now we need to get x. So staring at these equations, look, if we need to get x, we need to eliminate y. But look, there's a 3y and there's just a y. So how about we write the first equation as is. Again, u is equal to 2x minus 3y. And earlier we took the second equation and multiplied both sides by 2. Now it's going to make more sense to multiply both sides by 3. So 3u is equal to -3x plus 3y. Now add the two equations together. That will eliminate the y's. So by adding, we'll have, sorry, this should be a v here. So by adding, we're going to have u plus 3v is equal to, let's say those are gone, but we have 2x added to -3x. So we'll have -x. Again, to get x, we're going to just need to multiply both sides by -1 and have x equals -u minus 3v. So then we can set up the Jacobian. Maybe because we have room, let's just do this over here. The partial derivatives of x and y with respect to u and v. Let's see, so staring at this, derivative with respect to u, derivative with respect to v, so -1, -3, and then staring at this, derivative with respect to u, derivative with respect to v, -1, -2. And then, if we work this out, let's see, so 2, yeah, negative times negative, yeah, so +2 minus +3, right? 2 minus 3, in other words, -1. Let's take a look at the boundary pieces. Okay, so the boundary. So we didn't draw a picture. I guess we could, of this, but it's like, so we've got, like x equals -3. So that line here, x equals -3. X equals 0, y equals x, and then y equals x plus 1. So, I didn't really plan. Let's try this again. How about like this? So x equals -3 here, and you've got this vertical line. You also have that line. So this line, that line. Y equals x, and then y equals x plus 1. So like there's this parallelogram here. But the four pieces are, so x equals -3 is one of the pieces, another one is x equals 0, another one is y equals x, and another one is y is equal to x plus 1. So let's see what this x equals -3 translates into. What we need to do is plug in for that x, we have it right here, negative u minus 3v. Yeah, so this equation here becomes negative u minus 3v to replace the left side. The right side still just says negative 3. And if we just, to clean it up, because there's minuses everywhere, let's just say that this multiplying by negative 1 on both sides becomes u plus 3v is equal to 3. Okay, let's take a look at the next, please. X is equal to 0. Again, replace the left side with negative u minus 3v. We just have a 0 on the right side. And if we, again, multiply both sides by negative 1, just due to the convenience of minus signs, u plus 3v is equal to 0. How about y is equal to x? Well, replace the left side, which says y, with negative u minus 2v from here. And then the right side is negative u minus 3v. So we just replaced y, we just replaced x with what we had here and right there. Okay, and then I guess we need to add u to both sides, and we'll have negative 2v equals negative 3v. And if we add 3v to both sides, 3v minus 2v, so v is equal to 0. Oh, that turned out to be rather nice. And then let's take a look at y equals x plus 1. So the y on the left again gets replaced with negative 2 minus 2v. The x gets replaced with negative u minus 3v, and there's a plus 1. If we work through the same work as we just did, sorry, that box is probably actually distracting. Let me try to write that a little better. We're probably going to end up with negative 2v equals 1 minus 3v, and then that, I think, is going to turn into v is equal to 1 in the end. So let's draw a picture. Okay, so if we draw these 4 lines in UV space, it's going to look like the following. So we've got, let's try this again. Make this clean here. We've got like that. And so U-axis, V-axis. Of course, V equals 0, V equals 1 is easier to deal with, so maybe we'll draw that in first. There's 1, and then we just have a completely horizontal line. Great. But then U plus 3V is equal to 3. So let's see. If we plug in V equals 0, you get U equals 3. And then when you plug in U equals 0, V is equal to 1. So you have actually this line of slope negative 1/3. So that's U plus 3V is equal to 3. And then in the other equation, it looks like the line should be the same slope, except that because of the 0 right there, the point 0, 0, UV equals 0, 0 needs to be satisfied. So same slope as the line that was drawn, except going through the origin, should look, roughly speaking, like this. So U plus 3V is equal to 0. So the region that's bounded by this line and then the U-axis itself, it's this parallelogram. Okay, so this is this shaded region. I haven't shaded it entirely. I hope you see. I'll just shade it. And then where should I label that this is S? How about like over here, capital S? Okay, so if we were to describe S, UV, it makes sense here to say that V is going to go between two constant values, 0 and 1, and U has to go between, well, we need to see, at the smallest, the smaller U values are given by this equation, the larger U values are given by that equation. So let's see, solving for U, so negative 3V less than or equal to U, less than or equal to, and then solve for U here, 3 minus 3V. That work? Yeah. So now we'll set up an integral. The original integral over here, let's copy this and paste it down here. Let's also, because we've done kind of so many things, let's just grab these thingies. Oh, I'm not going to get the y that way. So let's take these just for reference and copy paste them down here. How about right there? Okay, so then this integral something to something, so v is going to be on the outside. Yeah, so let's just get the 0, 1 on there. Du will be on the inside, so u goes from negative 3v to 3 minus 3v. And then 2 times x minus y. 2 times the quantity x minus y. So how about 2 times, and then x gets replaced with negative u minus 3v, and then there's the minus sign, that's this minus sign, and then y is right here, negative u minus 2v, close parentheses. Now to replace dx dy, we need the Jacobian, which I already forget. Oh, it was negative 1, so let's get that down here. Negative 1 du dv. Was that the order? Yeah, v. Yeah, those are v values. Okay, so we'll be done with the problem here. Other than I'll just go ahead and do a little bit of simplifying. Just a little bit. I just want to point out that we could have 2 times, and then here, negative u minus negative u. That's going to be gone, right? We have negative 3v plus in the end, plus 2v. So this, all of what's in these parentheses ends up being just negative v. There is still this negative 1 du dv. Okay, so maybe just to highlight some common features, this here is dx dy. That's what negative 1 times du times dv is. The only reason I wanted to do this with this part that was in parentheses was you might, if you just get lucky, if you, let's say, just if you notice, now this kind of shortcut doesn't always work out, but in this particular problem, so any of the equations you have, as long as you properly replace, I just copied v equals negative x plus y from the original question. I just want to note that if you multiply both sides by negative 1, you have negative v is equal to x minus y. And I point this out because if we had just noticed this right away, that x minus y over here can just get replaced with negative v, fine. We did it sort of a more long-winded way here, but it works. So you can always just replace x and y. But if you see any shortcuts based on any of the other equations you have, just as long as you're being careful with your algebra and substituting things that are equal with things that are equal, then everything's going to be fine.